Hello, Jeff. Happy Thursday, 12:02 p.m.
Hello, Ian. How are you today?
Doing well. Rainy day here in Toronto, but excited to spend the day or the next hour, I should say, talking about the word that gets casually mentioned in every other sentence, which is AI.
AI, the buzzword.
Can't live without it. So thanks everyone for tuning in. For those who don't know us, my name's Ian. I'm one of the co-founders and CEO of a company called Select. Select is a Snowflake cost management solution. So we work with a lot of over 200 Snowflake customers, helping them optimize, manage costs. AI has been a interesting area recently, both in terms of the capabilities on Snowflake. Obviously, there's a cost element to it. That's not what today's session's about. We're here today to talk about all the different AI functionality in Snowflake, how to use it, best practices. I'm joined, and we'll obviously chat a bit about costs as well. I am joined by Jeff. Jeff, FYI, you're sharing your full screen. I'm not sure if you just
Yeah,
wanted to
I'm
get your
trying.
browser
I
up.
don't know what just happened. I'm just gonna take it off the stage for a sec.
No worries. So yeah, we are going to chat through everything around Snowflake's new AI functionality, what new features are available, what each of them do. This was like one of the biggest things in my head was when I first started like researching Snowflake AI functionality. I was like, holy crap, there's like 6 different services under this umbrella called Cortex. And I have no idea what each of these do. So we're here to demystify that, talk about best practices, and also we'll touch a bit on like how you can actually monitor these things from a cost and performance perspective. So I will turn it over to Jeff, and yeah, take it away.
Cool. Thanks, Ian. So I just want to start with hopefully getting people a little bit excited about this. So I've been working in tech and data for a long time, and I know what it's like to feel fatigue around having to learn a new skill like every 6 months in order to stay current. And it can be like really frustrating to feel like you constantly have to upskill. But Snowflake has made this actually pretty easy for us to seem like magicians to our business stakeholders and to our customers. So I really want you to get excited about learning some of these skills today because they're pretty easy to implement and they're really powerful and they're going to really bring you to that next level. And ultimately, this is a skill that we all have to learn. If you're a data engineer, especially, I think most people that join these webinars are technical practitioners. We can't just be data people anymore, right? We kind of have to be AI people, otherwise we get left behind. So buckle up. It's going to be a fun ride, but nothing in here is like really crazy hard from an engineering perspective. So that's what we like.
Yeah, in true Snowflake fashion, they make it super easy to use, deploy, set up all of these solutions. And what's exciting about this, if you work in data, like you have a great opportunity to, most people already did this. If you're good at data, you're like a wizard, but you will be even more of a wizard, when you equip yourself with these things. So it is an exciting time, and you'll hear us saying that, and it like may sound like a canned line, but it is very much genuine.
Absolutely. Here's a quick look at the agenda. I just want you to kind of begin with the end in mind that these 3 services, bullets 2, 3, and 4, and 5. Okay, so these 4 bullet points kind of all go together as the super skill that I want you to really walk away from today and like get really excited about. Like right after this webinar, turn off the webinar and go build Snowflake intelligence, basically, like turn something on. So that all goes together. But let's kick it off with the AI SQL. So what is AI SQL? So it's just adding a SQL function to a select statement. And if you can write a select statement and you can write something like a case statement, you can already do AI SQL. You just need to be aware that it's there and look up the syntax. So I've shared one syntax example on the right side of the page for a function called AI classify. And it's basically you give it a column, which is the text that you're trying to have it classify. And then you give it an array of outputs that you want to show up in this column when this select statement materializes. So it's really that easy to do data science activities, which we used to have to either use Python or some specific programming language to run machine learning algorithms on our data. But boom, now we can just do it out of the box without much effort at all. Just knowing that these people are.
This, I think, is a great example, if I can chime in here, and something I want to highlight. So I used to be one of said quote unquote data scientists. Prior to two jobs back before my current job, I worked at Capital One as a data scientist, and there was a big TV screen in the office that was tracking customer sentiment over time. And one of the big metrics we wanted to, track was net promoter score. And you could use like call transcripts as a predictor of that. Point of me bringing that up, this is a very common use case of you have transcripts, whether that's a call transcript, a customer feedback someone submitted, an email to your support team. You have all this text data. And we had like a team of people who were just trying to use, traditional machine learning algorithms and different ways to measure sentiment in all this data, so that we could then track it over time and understand, how the business was doing from that perspective, from the customer lens. That whole department, like what you're seeing on this slide, is an entire team of data scientists, and like, call it like 6 months of human time per year is like literally done in a second. So just to put that in perspective, this was back in like 2016, 2017, companies collectively, if you think about like the salary, like $500,000 a year easily on solving this problem that like Snowflake has solved in a SQL query that runs in probably 10 seconds.
Absolutely. Absolutely. Huge enablement here, right? So David Pollitt asked, does Snowflake call these Cortex AI SQL, or do they call them Cortex functions? And the answer is both. So if you Google search AI SQL, you can see that they are putting all of these Cortex functions under the umbrella or branding. So think of Cortex AI SQL as like companies being super brand aware and like trying to make everything brandy and flashy, but really Cortex functions is like the more technical term of what's going on.
If you are a select customer and on this call, we call this Cortex functions in our product, which I'll show in a screenshot. I recognize the name David, so yeah.
Cool. So how are these things priced? It's based per token per model. So some people probably don't know what tokens are. Think of tokens as approximately 4 characters. I wish it was like a more straightforward definition, that like maybe like they could have made 1 character a token or something, but whoever like came up with this token thing, it's like pretty universal. It's approximately 4 characters as a token. And over on the right, I have a pricing example of analyzing 20,000 product reviews with 100 tokens each. So all of these pricing examples are for processing 2 million tokens. And so you could do it for $1.92 on a mini model, or you could do it for $72 on Claude Opus, which is like a very large model. So keep this in mind as your biggest price lever is model selection.
Jeff, I have a question. Is there a way for someone to estimate the number of tokens in like a SQL statement? Or maybe this will be a feature request for Snowflake. Like, can you figure out before you run something, how many tokens is it?
You can figure out your input tokens before you run something by calling a function, actually, which is right. I'll come back, but it's right here, AI count tokens.
Okay.
I just looked this up before the call. It only counts your input tokens, which is going to be minuscule compared to the output tokens, which is you're running it on 1 million rows, and every row gets output tokens. Your input tokens is just the question you asked. So I don't see a huge value in this. These best practices are actually sorted, but let's come back to that. But that is my best answer at your question right now, is that. Cost monitoring, they give us 2 separate views in the account usage schema to monitor these costs. One is at the hourly grain, and then we actually have a per query grain view as well. So we're not going to spend time here, but the slide will be included on our website.
And yeah, Jeff's written a blog post on each of these individual features, and every post I made sure, thank you, Jeff, who did all the hard work, I asked him to include like how can you monitor this snippet? So these are 2 really nice views that Snowflake put together. The first one is a more aggregate level view. It's just going to show you like cost by function over time. Where it gets really interesting is on this second view here, where you're at a query level. You have the cost reported. So one of the cool things you can do with this, if you go to the next slide, Jeff, like if you're a select customer, for example, we help you very easily monitor your Cortex workloads. So, or your costs coming from these Cortex functions, AKA Cortex AI SQL, used interchangeably. The key thing you need to think about if you're a platform admin responsible for monitoring usage and costs and performance on your Snowflake platform is, again, I talked about how powerful that new capability is of you could run a SQL query and you get this magic out. Of course, you just need to be conscious and monitor cost to make sure that's adding the right value for the business. So one of the cool things we do in our product that you can obviously, try and build yourself if you are, maintaining an in-house solution and have a team who can do this, you can track a fully loaded cost. So like something we try and show our customers is you now have kind of a couple different components of a SQL query. It can drive compute costs, but it can also drive Cortex LLM costs, right, from those tokens that Jeff talked about. So this is how we leverage that information in the that Snowflake presents back to us in those account usage views as like another mechanism to track these.
Let me unmute here. Nice, perfect. Thank you, Ian.
No worries.
So Joan asked for AI classify function specifically. I guess it's only able to do it if it's trained or understands the classification category. So Joan, my take on this is it's using the great power of LLM. Like if you ask ChatGPT to say, is this tweet positive or negative? And ChatGPT would be able to tell you, right? So it's harnessing that power and not so much like conventional machine learning training is my understanding of what's going on there. Let's see, is there another part?
Yeah, I'd echo that. It doesn't need to be trained, or especially for tasks like this. There's another one here from Sridhar, not the CEO of Snowflake, Sridhar, different Sridhar. What is the recommended way to reduce the cost in when using AI SQL? How to use it wisely without consuming more credits? Well, what a perfect slide to talk about.
What a perfect slide. So thank you for teeing us up, Sridhar. So we already mentioned, use the smallest model that works for your situation. Mini models are actually really good at sentiment analysis and things of that nature. If you think that ChatGPT from 2 years ago would be really good at answering the question that you're asking it, then use that model, which is considered a mini model. Another way is to prompt the AI to keep the output short. So if I say, let's say it's analyzing a bunch of articles. So you actually have loaded records from a particular publisher, and it has every article from a publisher as a table or as a column in your database. You could say, summarize this article or summarize these articles, but you would say, please keep it to less than 40 words. Now you've kept the output tokens very small. So you prompt the AI to keep it short. This is extremely important, is cache your results. Don't do full refreshes on AI generated columns. So if you think about DBT models, an incremental model would help. Or whatever data modeling technique you use, make it incremental. And this one, based on my current understanding of this AI count tokens, I don't see this as an extremely powerful cost optimization thing, but it's just something cool to be aware of. This one with the AI underscore prefix is a little bit newer, maybe even in the last couple of weeks. Before it was just called count underscore tokens. They still both work, but Snowflake is recommending to use AI underscore. I don't know the difference yet, but I saw that came out recently. So
yeah. So can we go back? I just want to make sure everyone fully gets the third bullet point on the slide, because I think it's probably the most important one. And this is true of just a universal optimization technique. The cheapest way to process data is to not process it. The best way to reduce your LLM costs is to do less LLM calls. And how do you do that? Is by only processing the data that needs to be processed. So when you hear Jeff say, don't full refresh on an AI generated column, imagine you have a data pipeline which is building a new data set, and that's running every day. The very simple way to set that up is you have like a create or replace table as, and then you have a SQL query that defines what that how that table is constructed. So what you want to avoid, especially in the world of LLMs, is having like that customer reviews example. Like instead of running that SQL query every single day across, a billion transcripts, that will get expensive. So instead what you want to do is say, hey, let's only rerun this once we've categorized the sentiment of a transcript once, don't do it again. So that's the whole idea behind incremental processing. And this will not only lower your LLM costs, it will also lower your compute costs, which are also, can be a big driver as well. So I think that third bullet point, only process the data that needs to be processed. I will repeat that until my graveyard, or if I like suddenly exit the world of data. That is like the number one most important technique. It applies to the world of compute. It applies just as equally to the world of LLMs.
Absolutely. 100%. Okay, so Cortex Analyst, this is your text to SQL. So this is where you are now building the underpinnings of what becomes a chat interface for your users. So this is usually leveraging something called semantic models and semantic views. I'll discuss the differences between those two in just a second, but I just want to continue drawing the picture here, which is where are you using Cortex Analyst? You're either developing homegrown apps, like a homegrown web app, or you can embed it right in Slack, Teams, or this new UI called Snowflake Intelligence, which we're going to discuss many slides down. So semantic views versus semantic models. If you had to pick one, I would now pick semantic views. It's the newer feature, and it's what you can have a lot more power over fine-tuning. So a semantic model is a YAML file that sits in a Snowflake stage that the Cortex Analyst has access to, and it describes the columns in a very similar way to that I'm describing columns here in this very tiny screenshot that hardly fits on the page. But the semantic views you can query directly, and you can train the model based on it can ask example questions. If it gets it wrong, you can change the semantic view to rinse and repeat until it's getting the question right, and then indicating that as a verified SQL query. So I really recommend using semantic views and what we call the playground. I know this is a pricing slide, but we have an example of what the playground looks like over here, where I ask a question, explain the data set, and it explains the data set. And if it didn't get the question right, I would change that semantic view until it gets the question right. This is maybe not the best example because this is cool though. This question did not use a warehouse since it read the semantic view descriptions.
Yeah, for those who can't say, it says the question is explain the data set, and then it spits out a response.
Yeah.
Maybe if we just jump back to give I don't know if any of the folks here are coming from the world of Looker. I think actually, well, I know there'll be some folks in the world of Power BI, and I think they have a similar concept of, I think in both so if you're in Looker, you have something called like LookML, where you define like your dimensions and measures. So like your metrics, how are they calculated? They can be derived from other columns. And in Power BI, I think I've never used it, but I believe there's something similar where you like in Power BI, you define a data set, and then you also define like what metrics or measures are available. So the best analogy I have for Cortex or for semantic views is it's kind of like Snowflake's version of LookML or whatever the equivalent is called in Power BI. Maybe someone on the call can tell me what the Power BI version is with DAX or whatever. Semantic views are like Snowflake's equivalent of that, built primarily for AI. You can use semantic views so if a BI tool like Looker, or actually Looker never will, but like Hex, for example, will probably have support for semantic views in Snowflake, meaning you could like point Hex to a semantic view, and then your user could do aggregation this. So there's that use case exists, but the main use case is this is like metadata for AI, so it can more accurately answer your questions. So think about this. It's like you could have this GUI to edit it, or there's like a YAML file, which people will version control and use that to control their semantic views. It's context for AI, and Snowflake has made a very good service at taking text, using the semantic view. So the AI can say, what's this user asking? Okay, what columns, what filters do I need to add? What metrics? And then it can spit out extremely accurate SQL, because it's Snowflake knows what is valid Snowflake SQL or not, in order to answer that question.
Yeah, and you can use these descriptions as mini LLM prompts. So I had a situation where I was asking, like, what is my total opportunity pipeline amount? And it kept on using a column called like opportunity forecasted amount. And I was like, then I went to that field and I said, if someone asks you what the opportunity amount is, never use this field. Instead, use the field called opportunity amount, not opportunity forecast amount. And then I went to the actual opportunity amount field and said, always use this field, right? So you treat these descriptions as mini LLM prompts on every single field, because that's basically what's happening. Okay. So the pricing here, it's a little bit expensive, guys. It's 6.7 credits per 100 messages at $3 a credit. 10 questions will cost about $2. So it's not like a unlimited ChatGPT subscription, etc. But
when does that come out? That's a question for other Sridhar. Yeah, give us the unlimited subscription on Cortex Analyst.
So it's extremely powerful, but it's not the cheapest thing in the world. But it's also like, I mean, it's not the most expensive thing in the world. If you get 100 questions for $20, and those 100 questions really change the direction of your day, that could be absolutely worth it.
Yeah, I will. I'm gonna pull up a couple questions here. So this says LinkedIn user, but the name is it's from Brad Penwarden, who's a great guy, one of our customers. And he basically said, so to come back to my previous point, so just to reiterate, like, it sounds like AI generated columns may want to be excluded or isolated from your standard dbt flow. Just coming back to this, touching on a topic I talked about earlier of, like, one of the best ways to reduce costs is only do it in incremental flows, or try and use incremental flows, wherever. So my question is, like, you can and absolutely should use AI SQL functions in your dbt models, but you want to be careful if you are putting them in a model that does a full refresh, because it's going to be rechurning all the same messages through the LLM every time it runs. So I never give a blanket statement of, like, don't do this ever. It's just like, be careful, or, like, be considerate if you are doing it here. So that's kind of the note there. And then he also
no reason to not use an incremental model, right? I mean, it adds a little bit of complexity, but especially if you're using AI SQL, you're just gonna be so much better with an incremental dbt model.
Yeah. So you could definitely use AI SQL in your flows. Brad also asked, and I don't 100% get this question, is there any difference between the semantic model YAML versus views on cost informants? Is it talking about, like,
so there's semantic models and semantic views, and they both have almost the exact same YAML syntax. So people are always confused. What's the difference? The semantic view, you can actually write a select query against, whereas the semantic model, you cannot. It's just metadata for the AI. The semantic models don't cost anything, and neither really do views in Snowflake. It's querying it. So the question really is, like, when I tell the AI to write text to SQL, which one's going to be more performant? I like the semantic views because you can have what's called verified queries. By using this playground, you can type questions over and over again, and when it gets a question right, you click verified query, and you're training the model with those verified queries. So I just recommend views for that reason. Cost is probably about the same.
Yeah. Okay. Here's a great point by David that is worth calling out. So 0.2 per question isn't bad if you'd otherwise ask the same question in plain English to a human analyst. So this is spot on. As much as us nerds, like cost nerds, are like, oh, the per question price, maybe. It was like, excellent point by David. Like, let's zoom out and think about how expensive humans are. I love humans, by the way, and I hope we survive. But this is very cost effective in the grand scheme of things.
I have more to say about that when we get to the best practices slide as well, for sure.
But great point by David.
So for monitoring, we have quality monitoring. So in your interface, the users can give a thumbs up, thumbs down, and that feedback will come here, which is really cool. So here, Snowflake is showing you every question ever asked of this semantic view, and what the output was, and the feedback from the user. So this is pretty cool. And then we have cost monitoring. It is per hour per user. There is no like detailed view, or there's no direct way to associate a query ID with Cortex Analyst. You can use a separate warehouse, role tag, etc., to associate query history with Cortex Analyst, but they don't give you like, hey, this SQL query that ran on a warehouse was actually generated by Cortex Analyst.
They may actually, I'll have to look. I'm pretty sure they have like a comment in there that's like generated by Cortex Analyst.
Okay.
However,
Query comment
Snowflake
would be
Snowflake product team. Well, it's helpful, but I have a request, Snowflake product team. If you're listening to this, it would be very helpful if there was more metadata in that query comment, so you could understand like what semantic view was that for, who is the user that like where that comment originated from, like pretty much all the other contextual information, so that you can understand, hey, you know, so a hot take, I'll interject hot take here, like analytics engineers, you know, flash forward five years from now, they may just be semantic model engineers now, where they're just maintaining, curating, monitoring performance costs, success rate of their models. How do you what is a key element of this future role? The ability to understand performance of, you know, performance and costs of all of the queries generated by a particular model. So that would be a request to the product team to enrich that comment with more metadata, kind of like that Cortex function usage history view, where you have per query ID, you know what model did it call, you know, who called it, how many credits did that use. It'd be great to have the same way of what query came from, maybe even what was the question it was asked as well.
100%.
I'm sure they're always advancing those views, so I'm sure
probably worth enhancing our blog post to talk about those query comments, so I can do a little research there as well.
Yeah, I may have dreamed this. I tend to dream in query comments, but I'm pretty sure there's something there.
Okay, so how do we get the most accurate responses out of the Cortex Analyst? So use the playground. So go ahead right after this call, build a semantic view, figure out what the playground is. It's right there in front of you in the Snowflake UI, Snowsite UI. Start asking it questions. If the answer is bad, change the semantic view until the answer is good. Or since you're actually training with example questions, you can put a little prompt, like instructions in that question, like, what is my sales? Parentheses, use this field when someone asks that question. Go. And then it'll give you the actual like correct answer. Then mark that query as verified query. Then anytime someone asks a similar question, it'll say, oh, I found a verified query similar to this, and it'll use it. Synonyms are important. So like revenue is the same as sales, is the same as like XYZ. So if a field has synonyms, find out what is your business users call it. Meet with them. Say, how are you going to ask this question? What are the words you use to describe this field? Figure out all those synonyms and go nuts with these synonyms. Extremely important. I already mentioned this, so treat the descriptions of the fields in that YAML file as LLM prompts. And this we talked, actually, this is just general everything in Snowflake. Always use the smallest default warehouse size. Yeah. So let's keep going.
You should get I only use extra smalls like tattooed on your forehead or
oh, that would be funny. That would be
or on your hand as you're typing. You remember to use an extra small.
Extra smalls.
There should be a hat. We should make a cool hat or shirt that's like, or maybe it'd be funnier if it said I only use 6XLs. That would be more of the flex, I suppose.
So Cortex Search, what is this? So this is the ability to query a column based on the semantic meaning of that column. Like, show me all rows with complaints. Or in a vendors data set, you could say, which one of my vendors are consulting vendors? Or which one of my vendors are technology vendors? If you were trying to do this in pure SQL, you would be stuck to like regex and wildcard I-like searches. But now we could say, point an LLM at a column and ask a question about the data that's in that column, and get a filtered set of rows as a response, which is pretty cool. They have this proprietary model called Arctic Embed. So that's a little bullet point that it's so the way it works under the hood is it takes that column that you want to put search on top of, and it vectorizes it. So if you don't know what a vector database is, this is how LLMs work under the hood. It turns all of the text on the internet into these like 3-dimensional data points that are like floating in space. And so if you say like Facebook, the LLM goes, oh, I'm going to kind of look over here. So vector databases are just like how LLMs work under the hood. And so it'll take that column,
So hot right now.
it'll vectorize it, and so that it can understand it and search it more easily. Usually used by an agent in combination with Cortex Analyst. So we'll talk about agents in a second. This is a very reasonably and generally priced service. So the serving compute, so it works, there's two aspects of what you pay for. There's serving compute and embedding compute. So the serving compute costs 6.3 credits per gigabyte per month. So it's obviously a lot more expensive than regular storage, but you're probably, I mean, depends on how large the columns are that you're going to index. It's not terribly expensive. And then this is very cheap, the embedding and indexing activity. They're only charging 5% of a credit per million tokens. So it's one of Snowflake's cheapest AI services. So the actual act of embedding and translating that human text into vectors, right, is very inexpensive. But then storing that, it runs continuously whether you're there or not. So while this is up, you're paying for 6.3 credits per GB per month. And then you're always going to be using warehouses, storage, and cloud services. So this is just kind of below the line. We don't need to talk about it. Let's keep going. Monitoring costs, they do give you two views, and the examples are found in the blog post, but they give you a daily by consumption type, serving versus embedding. So it's like a cost summarization view. And then they give you a detailed view, which is hourly serving credits. So it's still not, yeah, this is about as detailed as you would want it to be, I think, though. So it's how much you're paying per hour. So if you have the thing on and off throughout the day, maybe you would want to see if anyone is resuming it and suspending it, etc. And then best practices. So suspend services during development. Otherwise, you're paying 24/7 for that serving compute. Choose columns wisely. Don't just like index everything because you pay for all of the data that you index. Set a longer target lag. So this kind of works like dynamic tables. There's a target lag argument in the create search service statement. So you could say, hey, I just need this to be up to date once a day. So you set that target lag to 24 hours. And then that refreshing compute, this part is only running once a day, or you could set it to 1 hour, but don't set it to every 5 minutes because you probably don't need real time. Real time is expensive.
And this is to rebuild this is like refreshing that like index or vector database under the hood that it builds.
Exactly.
Could you go back to, so just skip back 2 slides to like the entry point? I want to kind of rewrap my head around. For everyone listening, Jeff did all the hard work here. I'm mostly here to ask questions and provide commentary. So I'm still ramping up as we go. So when
which
someone
one
uses,
is this the slide you want to see?
First was on the use case for it. Like, do you ask, is Cortex search like something you call in a query, or is it like an API call almost of like search for this and all you can ever do is search for something in just one request?
So picture your chat interface, like your chat GPT interface, and the query, the customer or the user says, show me all of my vendors who are consultants.
Okay.
Now there's 2 ways you could do that. You could do that with a select and aware clause, or you can let the search service figure it out.
Okay, so it can be used in a where clause in a SQL statement.
Yes, it's used for filtering rows.
Okay, got it. I see. So think of it as like a where. Okay, this is like a really good where filter is like the mental model for it.
I think so.
Okay,
yep,
got it. Yep. And then can you go to the pricing slide again? Got it. So this 6.3 credits per gigabyte a month of indexed data. Would that be? Like,
it's serving that vector database to you, basically. So it's the search service is available and turned on. So if a customer initiates a chat that requires search, the agent will say use search because it's turned on. Otherwise, they're going to be left to traditional SQL devices.
And is that like a fixed cost throughout the month? So it's independent of you're just paying for the static cost of that indexed data while the service is up.
While the service is on, because you can suspend the service.
Right. Okay. So it doesn't fluctuate based on the number of questions or times it's
Correct.
being called. The only thing that would fluctuate there would be the warehouse compute that is responsible for actually executing that. So this is really, you're just paying for that stored data set.
Yep.
Okay. Cool.
Cool.
Thank you for clarifying.
No, absolutely. If Ian, if you have a question on it, that means almost everyone probably has a question on it. So that's really important to go back and clarify. So suspend services during development. Choose columns wisely. Set longer target lag. Okay, we did all of these. So now we have Cortex agents is a single slide with 2 bullet points, and that's everything you need to know about Cortex agents. A Cortex agent orchestrates the Cortex analyst and the Cortex search service and other custom tools that you can add to it. So you can build a custom tool with a model of your choice, and it's all built right into the Snowsite UI. So you can do this, and it'll call the right tool to answer the right question. So depending on what question the user asks in the chat interface, the agent will decide, hey, do I need to use Cortex Analyst for this question, or do I need to use Cortex Search for this question?
Right.
That's the agent's job.
And as go ahead.
I was just going to go to the next bullet point. So if you have a question on that first one, now's good.
No, I was just going to help like try and stitch all this together, because this took me forever to like understand and wrap my head around of like all these different things. So yeah, as Jeff said, just to reiterate, agents are just a layer on top that uses these underlying building blocks you have. And for Cortex Search, as a reminder, think of it as a really good where filter on text fields. For Cortex Analyst, think of it as a more general purpose. Ask any question about your data, and it will construct the right SQL query to then answer that. So I think there's a relevant question here of I've only used Cortex Search querying directly a table with unstructured data to build services as rags. But as you've said, this is normally also used together with Cortex Analyst. Could you share an example use case? So it's actually like this, it would probably be this use case here of like, if you want to build a, I don't know, customer support agent, and there's a number of, there's a number of questions that you'd want that support agent to be able to handle. Some of those questions may require a SQL query, an arbitrary SQL query to be generated to answer that question. Like, how many tickets per month have been closed by this agent? And it would go and use Cortex Analyst to hit the semantic view, figure out how to construct the query, run that query, get back the result in like a chart. Where search would play in is it's like, find me any calls where, the customer complained about Jeff's beard. And then it would call Cortex Search and like look through the text, hit that vector database. So that's how those two would be combined. And of course, the last question I asked would return 0 results, because I don't think anyone's ever complained about Jeff's beard.
No one is complaining.
Maybe his wife.
Well, unless my father is a customer, then you would definitely have a complaint about the beard. But yeah, short of that. And so Todd asks, in Select, are all of these cost AI SQL, search, etc., bundled under Cortex functions?
Yeah.
Ian?
Todd, great question. So today in Select, we just support AI SQL. So that would all be bundled under the Cortex functions. We do have support coming out for the other services. Part of our ability to support those is bottlenecked by the metadata that Snowflake provides. So in certain services, we have to wait a bit longer. Other ones, we're able to provide that more quickly.
Cool. All right. Snowflake Intelligence. My favorite, this is like the grand finale here of like what we can do with this, and why I'm saying that this is really easy to work with, because you've built a semantic view, you've built the analyst, you've built the search feature. All of that was pretty simple. Now you need a web app to expose to your business users. You don't have to create a web app. They already got you covered. You can log right in with your Snowflake credentials. So it's ai.snowflake.com. It works with the same SSO. If you have access to Snowflake, you already have access to it, but you can also, your business users don't want to see databases. They don't want to see schemas. They don't want to see all of this stuff that's confusing to them. They want to log into something that looks and feels like ChatGPT, and that's it. They want it to be familiar. They want it to be comfortable and non-techy. They want it to look cool, which it does. So that's what this is. It's just chat. And there's drop-down menus like which agent do you want to use? And for sources, this drop-down that says auto here, the choices in that menu are just going to be analyst or search, which is the two that I've given it access to here. And the chat history and in-app feedback show in Snowsight, which I showed many slides ago, where I said users can thumbs up and thumbs down every response and give feedback. That feedback shows up in Snowsight for you, the model builder, to make things nicer for them.
Yeah, it's very cool. So Snowflake Intelligence is kind of like, I think of these almost as like a pyramid, right? So at your bottom of the pyramid, we need to make this like a post of like the pyramid of AI building blocks in Snowflake, where it's like at the core, you have, your data sets in your tables that live in Snowflake. You then have semantic views or Cortex search services that you define. I saw this, too good. You then have semantic views or Cortex search that you would define on top of all those different tables. You then have agents, which you can then use to organize collections of, Cortex search and Cortex analyst, or sorry, semantic views. You'd have collections of those that would be bucketed into agents. So the example I gave would be like customer support agent or marketing agent, right? And the whole point of that is really just organization, right? So if someone's goes into Snowflake Intelligence, which I think in the mental model is like Chat GPT on your data, right? On your structured, secured Snowflake data is the mental model for Snowflake Intelligence. If they go in there, the beauty of that is like making the job easier for helping Snowflake provide more accurate responses, where if like someone's coming in to have questions about marketing, or the other example I gave with like customer support, want to see how often people are complaining about Jeff's beard, they can then select the relevant agent, and then all the questions Snowflake will know that it's going to be searching those different tool blocks. So that's kind of hopefully the way to like think about all these different AI services, like a pyramid. You have like your data at the bottom, then you have the Cortex search or semantic views and models you put on top. Then you have agents, which are just like collections of Cortex search or analyst or semantic views. And then you have intelligence, which is a collection of agents that you then expose.
Perfect. So here's what I really like about it. It's not perfect, so we'll do the positives and the negatives here. So every question is answered in advanced reasoning style. So if you ever use Claude Code, like when you ask Claude Code to do some work, it builds out a checklist and then it goes through and it makes sure it did all that checklist. And you could see it like chatting with itself. So advanced reasoning is like the LLM kind of saying, oh, I understand the question. Let me think about this. And you can actually see the thoughts, quote unquote, thoughts of the LLM and how it's working it out. It takes a long time though. So that's kind of one of the cons when it does this advanced reasoning. It's not like instant like ChatGPT because it's doing this reasoning mode. So here you can see planning next steps. This is what it looks like when it's doing advanced reasoning. And it says like, first I need to get the data they want, inform the user that the question they ask is not supported. I asked for scatter plots, and then suggest an alternative visualization that might work for available chart types. Just funny. So the app is very slick and requires no setup. So it is a really nice UI that like business users will want to log into and work with. It will always opt to include a chart if possible. So that's a nice little feature that they built in. Like if the data is chartable, it will chart it. Snowflake credentials work great. So it's very easy to log into and manage. You don't need to build your own authentication software. And I think the main point here is that this is the easiest way to enable AI at your organization. This is how you're going to look like a superhero. And then you go laughing and say, ha, it was actually pretty easy.
That's great. Before we get into what you don't like,
Okay,
maybe I'll get into this. Well, there was a question on feedback tracking. Sounds like Ben mentioned he's been able to use this Cortex analyst request to get feedback on Cortex analyst. So like the plus minus. Do you know something similar exists for intelligence itself?
Um,
Like tracking the
no,
thumbs
because
up,
the
thumbs
Snowflake
down?
intelligence just uses the analyst under the hood. So the feedback that they give there shows up on the Cortex analyst screen.
But what if it hit the search, right?
Yeah, I'm not sure how
Yeah.
that shows up.
Okay. So Ben, maybe a good one for the Snowflake support team. And then here's another quick question on is it
Yeah.
possible to add a Streamlit app as part of an agent? That's a great question.
Yeah. So anything that you do with Cortex Analyst, whether you put an agent on top of that, then you could build your own custom app or use the app that Snowflake gave you. So you could absolutely build any app in any language that you want to, including Python/Streamlit, to expose a chat interface. But
But
Streamlit
I
is
think
cool, but it doesn't look the best. It's not like a really nice.
so. I could be interpreting this. My interpretation of
different.
Dimitri's
I'm
question
interpreting.
is like, as you're going through, could your agent spit out a Streamlit app for the user and then they can go and like adjust a toggle? I'm like 90% sure the answer is no as of today, but someone at Snowflake can, okay, let me count. I'm 70% sure. The answer is like, you cannot have an agent spit out a Streamlit app. I'm like pretty sure that's not a thing yet.
Yeah, but Claude Code can.
Claude Code could, but yeah,
Absolutely.
Claude Code could do anything,
Yes.
except my laundry.
So here's what we don't like. The charts, if you ever use the charts in Snowsight, did you find them useful? Like there's a lot of chart types that aren't there. So it uses the exact same looking charts as what you have in Snowsight, and they're not flexible. And I tried to get side-by-side bars, like show like top 10 customers, this year sales, last year sales. And I wanted this year to be one bar with last year to be a bar right next to it. And the grouping is customers. And like, I couldn't get it to do it. So that's one thing I didn't really like. You're unable to pin analyses. And I know this is not a BI tool, it's a chat agent, but the really good chat agents out there, I mean, I'll shout out another tool. Zenolytic is one where you can chat and then you can pin an analysis. And then you could say, here's a question that I asked, and I'm going to ask you this question every day. Don't make me type out the question and do the whole thinking thing again. I want to pin this analysis. And now when I log into my pinned analysis, it should just refresh all of those SQL queries, which you already ran. And that's what I really want this tool to be able to do in the future is like, I can pin charts to a page, and then I go to that page and they all just refresh the basic SQL queries that update the data.
So this is a fantastic point, and Snowflake should pay you for all of the great feature suggestions you're giving to them. Actually, what Jeff just said is hereby protected by Select's IP, right? No, I'm just kidding. we own that idea. No, I'm just kidding. So this is a question from Tyson, who also complained about your beard earlier. So up to you if you want to answer this, Jeff. But Tyson Doberneck, if you know him, he said, "Would our business users need a Snowflake account in order to interact with the UI?"
Yeah, so you need to create a Snowflake user. If you use Okta, you would create them in Okta, but then don't grant them anything in Snowflake. So if they log into Snowsight accidentally, they don't see anything. But then, yeah, they need a Snowflake user.
Let me double click on that though, because my understanding with intelligence is it will just use Snowflake's built-in RBAC, right? So if Jeff, say if you give me access to your Snowflake accounts, you create a user for Ian, I'm like, I want Snowflake intelligence. What do you grant me access to? Do you grant me access to the agents, or do you grant me access to the tables that the agents queries?
So the agents and the semantic views, etc., are all schema level objects. So I created a database called like Snowflake Intelligence and a schema called like agents, and I put all those objects in the agents schema, and then I granted public access to that. So literally everyone in the company would then have access, but obviously you don't have to grant public. So to answer the question very directly is they need access to usage access on the schema where these objects are held, and they need usage access on the specific semantic views or agents in that schema. but then it
Okay,
doesn't
so this is really
necessarily give
interesting.
them
But
access to the data.
to the data, right? So you could have a schema over here which contains your Cortex analyst agent search stuff that queries data in this schema. So this the semantic view is built on top of a table over here, and by granting someone access to this Cortex or this semantic view, they're inherently getting access to the data in that table, right?
That's right. They're inherently getting access to the data in that table through chat only and not through direct
Right.
SQL query. Yeah.
But access is access, right?
Access
So
is access. That's right.
interesting world of security we get into here of like, I don't know. I'm curious now, like how, yeah. So Tyson, you'd have to give people access to the agents, and then you'd have to know that like, hey, this agent under the hood has access to all of these things. So fun thing for security minded folks to just think about and keep track
it's a
of.
fun security lineage DAG, right?
Yeah.
Like, what do they really have access to?
We need to do, we always need more DAGs, don't we? All right.
Cool. Let's go on to Snowflake Intelligence Pricing. It is absolutely free. The underlying services are charged, as we discussed. So
yeah. So that just answers this question from Sridhar. Thank you for sticking around, Sridhar, and asking many great questions. So yeah.
Yeah, Sridhar was on our last webinar too. I remember the name. So thank you, Sridhar, for joining us.
Nice.
The last service we're going to talk about, so that was the grand finale, right? But we have a little bit of like an encore, if you will, here. Document
dessert.
AI.
This is dessert.
This is dessert. So what is Document AI? So this turns unstructured documents into structured data. And the example that I can wrap my head around very easily is if you get invoices from a bunch of different vendors, every vendor has their own accounting software and their invoices all look different. So you need to tell the AI like, hey, I want to get vendor name, address, and the line amount, and maybe the grand total from the invoice. And I want you to turn that into a table, a structured data that I can then query. So you give it, they call it zero shot training. You give it like 5 to 20 examples, like labeled examples. And you then sick the AI model after it. So that's called Arctic Tilt, which is text image layout transformation. And this thing runs on a single GPU that Snowflake manages. And it'll basically take all of your invoices then and turn them into whatever columns that you want it to turn into. So is this making sense here? Should what questions come up here?
No, I think this is great. I will give another example. Back 2 jobs ago when I was at Capital One, again, we had a entire this was like one of the projects I owned and services I managed was how do you take, like, banks send out a ton of mail, we get a ton of mail back. Humans would have to read that mail and pick out the like account numbers, the customer names, all that stuff. You have to like parse out of the mail so you can then go look it up in the corresponding system. So again, another thing that literally costs companies hundreds of thousands of dollars a year, if not millions of dollars a year in like labor costs to just like read through PDFs or like hard physical mail that came back. I also had a summer job, like flashback forever ago, in like document control where I would literally look at PDFs, grab information from it and compare it to some spreadsheet. It was the worst job ever. But all that to say is, like, this is again just a perfect example of like you can run a SQL query and fully automate something that costs companies millions of dollars a year. So again, just think document AI, PDFs, images, anything with document data that's scanned, it's not structured. You can then output that into like, again, anything like pull out the customer name, pull out the content of what this is about. And then have that live in a table that you can then query or do whatever on it.
So the key point to segue into the next slide is that this uses Snowflake managed compute. So it doesn't run on a warehouse. They manage this Arctic Tilt thing and they run it on their own compute. And so here's the pricing. It's 8 credits per hour. So it's like medium kind of warehouse pricing. And here's some examples. So we have 100 documents with 10 pages each. We have low density and high density. And so your this is the number of credits depending on how many values you want to extract. So like if you want to extract 10 values from a low density invoice, it could be 4 to 7 credits per hour. So they're not charging you per page, which if you ask ChatGPT finds this information and tells you that it's priced per page, and they spit out this. It's priced 8 credits per hour. This is giving examples of how many hours it might take and the potential credit consumption. Okay,
Wait, so to be clear, ignore what's on this image on this slide.
Well, they are examples of ranges of like what you might pay, but this actually is more or less coming from the Snowflake documentation. This is not my ranges. These are Snowflake has a table which is really hard to digest, so I just tried to make this like easier to parse here. But this is roughly what it's going to cost: 4 to 7 credits per 1,000 pages on a low density to get 10 columns, right? So that's how it's priced.
Let's I just checked time and we have 2 minutes left. So
okay.
Oh, look at that. A per query grade monitoring. So boom, you have very granular usage tracking for document AI specifically.
Yep. And then here's our wrap up, our cheat sheet here. So these are all of the services we discussed today and a half a sentence on what they do.
All right, so let's rip through this. Cortex AI SQL, you can call LLM functions in your SQL. So you can generate new columns. I would say it's more than generate new columns. You can like, filter records based on AI. You can aggregate data sets and group by. So it's, you can do all sorts of things with AI in SQL. Cortex Analyst instead is a service that, think of it as more of a building block for applications, whether those live outside of Snowflake or in an agent in Snowflake. The job of Cortex Analyst is to take a natural language question and then convert it to a SQL query, which can be run that will answer that question. Cortex Search is another one of those fundamental building blocks that lets you ask very flexible questions across like a column of data. So think of it as like a super powered where filter you can stick on your queries that is like AI powered instead of using a regex. Agents, as Jeff said perfectly here, they orchestrate, they bucket together these tools that you could give a persona to. And then Snowflake Intelligence is the layer on top of that, which is both the UI plus the interface for interacting with all of these agents. And then document AI is actually probably one of the oldest AI piece of functionality that Snowflake's had around for a while, where you can again turn unstructured data, so think PDFs, extract meaning out of that. With that, I think we're at time. So special shout out to Jeff for doing all of the hard work here and putting together all the slides. And he's written, I think, 5 or 6 blog posts on this, kind of going service by service, talking about all those. We will post the recording on our YouTube channel, the slides to this on a blog post, and then we'll also share the links to those independent blog posts. So thanks so much, and we'll be back next month with another fun topic to be announced later. Cheers.
Cool. Thanks a lot, Ian. It's been fun.
See ya.
Bye. End stream.